Um, Hello, welcome everyone. I'm Kan Yu Chen, and today we are exploring two powerful creative thinking tools from a methodology called Trees and Smart Little People. Before anything else, can everyone hear me clearly? So the sound is good,
Yeah,
right?
Yes, yes,
yeah,
yes.
Okay,
Yeah, good.
so cool. So here we have today is Frank Shi and Tony Wang. So Frank, could you please just like introduce yourself a little bit, just like your background?
Oh yeah, yeah. Graduated in Okan Uni around 2 years ago, and I'm working in Oracle and in the geotech engineer group.
So civil engineering background and
Oh
geotech.
yeah, so
Yeah,
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 geotech. Yeah.
got it. And Tony, what's your background?
My name is Tony Wang, and we are the same graduate, but I graduated one year before, and I work in construction company.
Okay, cool, awesome. So
Yeah,
civil background, but like PM roles right now
yeah,
in
yeah.
construction company. That's awesome. So I've already recorded this meeting, so is everyone cool with that?
It's okay.
Yep.
Yeah, okay. So the duration of this workshop is around like 80 minutes. So it's gonna be a long one, but I want to try to keep it short. So here's our tonight's running order. So I've done the welcome and tech check, and then we're gonna start to some warm up the civil trade-offs to help you guys understand how the contradictions like lives around us. And then it's the tech part, the contradiction matrix. And from there, we will start practicing about the matrix. And then another technique kicks in, which is the smart little people. Also a practice on that. And then it's the sort of like a 2 minutes break. It's a long one, so we definitely need a break for like a water time, like 2 minutes break. And then from there on, once we both understand how the contradiction matrix, the traits work, and the smart little people work, we're gonna apply them to a worked example, the compaction example. I will talk you that in a minute, and then it's the idea voting and the shortlist, and then the feedback session. Also, we need to sort of come up with a smart plan to help to deliver this like workshop or content even wider or like in a like shorter time period. So, okay, let's go to the first part. It's the civil trade-offs and the contradictions. So, is there anything you guys familiar with the contradiction, like about this word? Do you know this word, contradiction? Frank?
Wait.
Just by word itself, the definition of the contradiction word itself.
Uh.
It's like a conflict, right?
uh oh yeah, like during
Yeah.
no,
So it's like a black and white thing. And so when we think about a real trade-off from a project or study, so is there anything you two can share about? So I will give my three ideas here. So the first one I think about is the high strength to workability. So we all know, so for something so like a cement, we want to have like a high strength. It's gonna reduce the workability. And clearly the speed of construction to quality. If we want to speed up the construction process, the quality might not be that good. So there's another contradiction we can find. And the third one is the cost and durability. There's clearly we can find the cheaper the material is, the durability is gonna be worse. So is there anything you guys can think about from either like the projects you're working on or the study we've taken on? Anything, Tony?
Uh,
probably I have one.
Okay, Frank, yeah,
yeah,
please
you
go.
first.
Oh yeah, uh it was during a pile construction.
Mm-hmm.
I
Yep,
did an inspection for this.
yep.
So the soil the soil was loose, so a pile casing was needed to install in the pile hole
Mm-hmm.
to stop the soil clasp
Yep,
clasp in the hole.
yep.
Um, but the casing made some voids between the a pilot hole and the casing.
Mm-hmm.
So we need to find some material to backfill
Yep.
the void.
Yep.
But I stress them to use grout. It's a liquid. It's a It's like a liquid material
Mm-hmm.
to the contractor.
Yep.
But they told me we didn't prepare this material. We only have concrete. Uh, so they want to use concrete to backfill the void. But
Mm-hmm.
you know the concrete, there's some aggregate in the concrete.
Yep.
It's like solid things, so
Mm-hmm.
cannot perfect backfill, cannot perfect fill up the void.
Mm-hmm.
So it will influence some like skin fraction problem, stability of the pallet.
Yep.
So I think that's the thing like cost and quality.
Cost and quality. Yep. Fair
Yeah.
enough. That's really a detailed example. Anything, Tony?
Uh, Similar like this one. When we do the foundation footing,
Uh-huh.
the earthwork is quite bad because they remove more soil,
Uh-huh.
so it's deeper than what level we needed.
Uh-huh.
So it's it got two methodology to solve this problem. The first one
Yep.
is backfill more
Yep.
gap 40 and hard
Uh-huh.
fill, and another one is use more concrete and make the footing bigger.
Yep.
So it's I think it's between cost and
Durability.
work time, I think.
Mm.
Yep. Yep. The cost
Yep.
and durability. Yep. Cool. Awesome.
Yep.
Thank you guys. That's pretty good. Think since you guys all understand this contradiction term stands for, so we will jump to the definition of traits. So let me share the original story of traits. So traits was discovered by a Soviet engineer, and he's also an inventor who analyzed over 500,000 of patents across industries. So he discovered that only 40 inventive principles account for the vast majority of genuine innovations, and contradictions are always at their core. The TRITS term stands for Theory of the Resolution of Invention-Related Tasks. That's the story of TRITS. So that gives us to the next part, which is the contradiction matrix. So to use contradiction matrix, we're gonna start from 3 steps. So the first one is sort of like a name your contradiction. So what do you want to improve? What get worse as a result? Let's use a coffee cup as an example. So I want the coffee to be hot, but not hot things can like really gonna burn me. So I don't want the coffee to burn me. So I want to keep the coffee hot, but outside the cup, I want it to be cold. So from there, I can see it's gonna be the contradiction between the temperature, which is parameter 17, to the harmful effects, the parameter 31. And then, since we have identified the contradiction, we need to find the matching parameter. So it's the just look up the 39 parameter list, that's the 17 and 31. And since then, we need to read the cell, the contradiction matrix. So we need to find the so like where is the improving parameter that's in the row, and the column stands for the worsening parameter, and the cell gives you the suggested intensive principles. So in here, we find out it's the 17 for the contradiction matrix. The parameters is 17 and 31, the temperature and objective generated harmful factors. And then we use this matrix to locate where the cell is. So remember the row stands for improving parameters, and colon is for worsening parameters. So we want to improve the temperature, but worsen the harmful factors. So in that case, we need to locate the row 17 and the column 31, which gives us the cell circle here in red. That gives us the change principle of 22, 35, 2, and 24. So in that case, for this coffee cup question, by using the contradiction matrix, we find the 4 principles that we can use to generate our ideas, which are the number 2, taking out, 22, blessing in disgrace, 24, intermediary, and 35, parameter change. Is there any question regarding that coffee cup example?
All good.
No question.
Okay, that's awesome. So we're gonna jump to the like a mini practice for you to think and use to apply the treat method. So the problem is for concrete, we want them to have high strength, but increasing cement content reduce the workability. So makes it harder to pour and compact. So just work through all these 3 tasks from A to C. You can discuss to each other or work separately and compare to think about the so like start with the parameter, the contradiction parameter, and then from there to go to the contradiction matrix, and then we can find out the principles to solve this problem. I'll probably give you guys 5 minutes. You guys prefer to work separately or discuss together?
Mm, Probably discuss or
Discuss together?
yeah.
Sure. Okay. So here's the 39 parameters of contradictions. You guys can just have like 2 minutes to discuss about like what are the parameters you guys gonna choose, and I will share my one, and then we can go from there.
I think
Yeah.
first one should be strings.
Oh yeah.
Number
Also yes.
14.
Yeah. And
So I got
uh
the question.
Yes.
So why use the more strings concrete can reduce the workability? Is that because of time? The concrete gonna
It's
be
because of adding the extra amount of the cement.
hmm,
oh
So,
lo-
so
lose.
for instance, if we have like a full of water, it's gonna be like really easy in workability. And it's like a full of cement powder, it's really hard to in workability. So sort of like in this situation here. So with more cement content, it's gonna reduce the workability. So I think that's pretty good
Mm,
for 14. That's strength one. That's definitely is it's gonna be an improving parameter. So you guys do need to think about the worsening parameter. So find the worsening parameter here. So we've got the strength, we know how to improve the strength, but workability part?
uh Probably convenience of use maybe. Yeah.
Yes, definitely. Convenience of use is similar term as the workability in this content.
Mm, mm.
That's awesome. That's the same as I would go from here, the strength and the convenience of use. So this is the matrix here. We've got the improving factor, that's the strength, the 17, and the ease of operation, the 33. And this gives us the principle of 32, 40, 25, and number 2. So in this trace principle, if we find them out, remember the 2, 25, 32, and 40, that gives us the idea of how these principles are. And then from there we can build on. From the taking out, we probably can separate the workability function. So like a add super plasticizer at the job site just before pouring. And for the self-service, use concrete mix on rheology or heat of hydration to active the workability aids. or like for the color change, use chemical indicator to signal when the workability is optimal without guessing. And composite material by replacing part of cement with supplementary materials like sand or whatever. So it's just like the idea we can think about from the principles to give us the like a more choice about the questions or the problems here. Is there any question regarding the treat method?
No.
No? All good, Tony?
Yep, all good.
Yep. Awesome. So let's jump on to the smart little people. So this is another technique I want to share with you guys. So where did it come from? So Oshlerha noticed that miners in a dusty mine could not see a solution. But imagine tiny intelligent particles choosing where to go unlock new thinking. By replacing the material with a crowd of tiny smart people who can think, feel, and rearranging themselves, we bypass fixation on existing form. So how exactly does this method use? So what we can do is first replace any material or substance with tiny intelligent people, and then ask, what are they doing right now? What's doing going wrong? And then we can redesign. How could they rearrange to fix the problem? And last, chance stay back. What engineer solution does this suggest? So it's just like a four-step thing by using the smart people to solve any like complex questions. So let's jump to this mini practice. So the question is, why does water pool on a flat roof? Describe the problem using little people and then redesign them to fix it. I will give you guys around like let's say 2 minutes to think about this one, and I will just ask you guys like the four questions show on the screen. Just 2 minutes to have a think, and then I'll ask you guys.
Yeah.
Yep. Feel free to ask any question if you have.
Mm,
So we just thinking the water like a small people,
Yeah, the water
and
water water particles like small little people there
yeah, understand stand on their
on the flat roof.
situation to think about how
Yep.
to do. Okay, yeah.
Yep. That's right. Yep. Okay, so I will just start from the very top regarding the first question. So what are people doing when the roof is flat? Tony?
So they stay where they are and waiting for sunshine to
So they're
remove
just like
them.
staying there because
Yeah,
there's
yeah, yeah.
no external
Mm,
force to force them to do anything, right? So they're just staying
yeah.
there, right? Okay, so why do they stay in one place? What stops them moving? Frank?
Uh, yeah, I think because of the roof is flat and the gravity cannot get them move move to the boundary of the roof.
That's right. Yeah. So
Yeah, gravity.
just like anything. So like a balls or anything, just like if they're staying on a flat surface, they won't move. So there's like no
Yeah.
external force, same as the question one. So no external force to make them to move. That's so like the answer to this one, right?
Mm.
And the third question, so what if they could decide where to go? How would they escape? Tony?
So uh, I got two options. One is make the roof make a slope for roof
No, no,
or
sorry, let's question four. I'm just asking question three there. So what if they
yeah.
could decide where to go? Just think about like so there's so like some smart little people. So what if they could decide where to go? How would they escape the flat roof?
Uh, uh yeah, waiting for sunshine.
Probably I think they will move towards to the lowest point.
So they try to find something that as to help them move
Oh
because
yeah, yeah.
they don't want to move themselves, so they want to
Mm.
have somewhere that's gonna help them to go, right? So let's
Yeah.
say a slope for them to move from the top to the end, so they don't need to stay at one place, and there's sort of like a solution there. So that brings us to question four. So what does this suggest about the roof design? As don't you say you got some ideas?
Yeah, make a slope or make a internal gutter, I think.
So that's what we think about. Just make them a slope, so they it can help them to move. So they don't need to like think about where to go. They just like there's a so like a external force to help them to move. That's what we can think about the roof design. That's why we see all the roof around here are using slope roofs. There's barely non-flat roofs, right?
Yep.
Cool, awesome. So we've conquered both two principles here, the trees and smart little people. Let me just refresh you guys back to the trees method. So Tony, do you still remember what are these three steps we need to do about the contradiction matrix?
Yep.
Okay, so what are these three steps?
Three steps. First one is individual your contribution.
Uh-huh.
Is that this one?
Yeah, that's right. So just like find the so
Uh,
get an understanding on the contradictions, right? For the
yeah.
problem. Yep. And what's the second step? Frank idea?
Find the
Uh,
matching.
wait. I mean, let's try to
There's
remember this.
something wrong with your
Uh,
camera. Can't see you. But that's okay. As long as you can talk, that's okay. So what's the second
camera.
step for the contradiction matrix?
I think I think find the parameter.
Find the parameter. That's
Yeah.
awesome. And then since we have the parameters, what's what we're gonna do on the next thing, Tony?
Read the call.
So the cell, you mean the matrix cell?
Yeah, yeah.
Yeah,
The
so
cell.
just
Yeah.
based on the parameters we identify, we need to refer back to the matrix and think about the improving and worsening parameters, and then we read the matrix to get the cell, and the cell's gonna contain the principles, right?
Yep.
Okay, so that's pretty good. Smart little people, we've just done that one. Just think about them as like a bunch of smart little people to solve your questions. So that's so like easy four questions to ask. Do you guys still remember what like the four questions to ask for smart little people principles? Like how to use it, the four-step thing?
Mm, wait. Mm,
So the first steps is gonna be like replacing what?
Uh, replacing
oh, r- wait.
any
Mm,
material.
yeah, materials.
Yeah,
Yeah.
with the tiny intelligent people, right?
Yeah.
Yeah.
Yeah, awesome.
Yeah.
So what's the next step?
Uh, oh yeah. Just imagine what they're doing, what they will do, and what they're doing right now, and
What's
yeah,
going
what's
on,
wrong.
right?
Yeah.
Yep,
Mm.
awesome, great. And the third question, the third step. What's the third step? Redesign.
How could they fix the problem?
Mm.
Yeah, that's right. That's right. Awesome. And finally, we just need to like translate
Like,
them back to think about the engineering solutions based on the suggestion, right?
yeah.
Yep.
Cool. Awesome. That's pretty good. So I will probably give you guys 5 minute break and then we will jump on to a real world example. Okay?
Okay. Mm.
Yep.
Cool. Awesome. So welcome back. How's the break? Pretty good. 2 minutes break.
Yeah, pretty good. Yeah.
5 minutes break. Okay. Awesome. So as I said, after a break, we're gonna jump to the main work example, which is the earthwork compaction, the speed versus quality. So thanks you two both are having a civil background, so you guys all understand how the compactor works, right? So you guys got a roller or hand-on compactor to compact the soil just before do anything, right? So before foundation or before driveway, we all need to do compaction, right, to make the soil condition better. So here's the problem, like common problem as we all may see during on the site. A road contractor needs to compact subgrade soil quickly to meet the program. They need to do it fast. But faster roller passes reduced compaction quality, leaving weaker, less dense soil that cause pavement failure. How do we compact fast and to high quality? So this is the problem we all gonna see on the side. So we need our contractors to do things faster so we can catch up the program or the schedule. But we also want them to keep the higher standard, right? So this is a really typical contradictions we're gonna face on site, which is the speed versus quality. So first, we're gonna use our smart little people principle we learned today. I will give you guys probably like 5 to 10 minutes to think about some ideas by applying the smart little people principle. Do you guys still remember how to use them, right? The smart little people principle. The
Yeah.
questions you're gonna ask the 4 steps.
Yeah.
Awesome. Okay.
Yep.
So I'll give you guys 5 minutes. I will have a check. If not good, I will probably push it to 10 minutes. Okay, so 5 minutes starts now.
Okay.
Okay, so how's everyone going? Got some ideas or still need 5 more minutes?
More minutes, thank you.
Okay, okay.
I think
Uh-huh.
uh so
No, idea doesn't have to be perfect. Just like any wild idea would also be good. You never know. So yeah, any idea is welcome. Okay. Got some ideas?
Can I
Yep.
try? Can I try first?
Okay, sure. Go.
So maybe I just want have a try first because I don't know is there any problem for on my thinking.
Okay. Yep.
Uh, um, so firstly, we replace the soil with intelligent people,
Mm-hmm.
and what are the soil doing? They know, so I think they know where already compaction and where hasn't been compaction yet. So what are they doing right now? What's going wrong? They don't know each other's, so they don't know where they are, and they don't know where already compaction and where haven't compaction. So how could they fix the problem? Think more intelligent computer are needed. So its outcome is intelligent compaction machine you need.
Okay, so it's like for the compactor to identify where has been well compact and where hasn't been well compact, and for
Yes.
that well compact sections, they can just go it faster. But for those like are still undone parts, so they need to like spend more time on those part, right?
Yeah.
Just use like a smart, let's say AI or like smart computers or sensors to identify the areas about like undone, right? Undone
Yep.
errors. Yep. That's
Yep.
really a good point. That's awesome. You wanna go for a second idea? Don't need to have second idea here.
Yes. Uh, but I just read half. So Frank, do you
Oh yeah,
mind? Yeah.
I
Okay.
can,
Yep.
I can share one. That'll be interesting. So I just imagine the soil to a smart person, and different type of people have different opinions.
Uh-huh.
So like someone go to IKEA. So one people think this bed is more comfortable, and the other think another bed is good.
Uh-huh.
So it's a little bit hard to make them with the same idea in mind. So like if we sell a person a wrong type of bed, they won't be happy. So like this problem. Um. So different soil have different parameters and different performance. So we need to find a we need to we need to try to like, identify like, which type of soil it is and try to find the best type of the roller,
Uh-huh. Uh-huh.
a correct roller to impact them.
So there's like different types of doors we can
Yeah,
choose from to suit
yeah,
different soil
soil.
conditions.
Yeah.
That's awesome. That's awesome. Do you have more ideas, Frank? Or you wanna only have
Uh,
a go?
oh yeah, I have another one.
Uh-huh.
So I just I imagine like uh because I was thinking about the soil thickness, the layer thickness.
Uh-huh.
So if if the soil is too thick, that means the smart person is too strong for me.
Uh-huh.
It's too strong. Like
Yep.
it's really hard to beat with them. So so like we need to find some way like to make them weak weak weaker.
Yep.
So I was thinking we can reduce the thickness so and then we can easily compact them.
That's awesome. That's awesome. That's one of the ideas of I'm thinking of. So just changing the thickness of the soil layer, right?
Yeah.
Okay. Donnie, you said you had a second idea, right?
Yeah. Uh, it's if I think if I replace the soil with intelligent people
Uh-huh.
and they just stay at the ground, um, so somewhere may too dry to so if there are some people, so
Uh-huh.
they could think so this place is too dry to get closer,
Uh-huh.
and this place is too wide to get stable.
Uh-huh.
So the outcome is they need a comfortable environment,
Uh-huh.
like uh, so we need moisture control.
Okay, so it's like changing the soil moisture, right?
Yeah. But
Okay.
so control the moisture in in a range. Yeah,
Uh-huh. Uh-huh.
no too dry or no too wet.
Uh-huh.
Yeah.
That's pretty good. So we have like four totally different ideas by applying smart little principle. That's awesome. So probably I will share some more here. So let's say for soils, think about them as smart little people, right? They're full of smart little people there. Just thinking of on a very busy subway or metro or underground. When there's a full of people in the cabin and there's some more people wants to add in, or let's say we want to reduce the volume they're taking off. So what we do, we just squeeze them together, right? So people are just like jiggling around to create more space, right? For some people to like jump in or going out, right?
Mm.
If the same method applies here, if we let the soil to jiggling around, does that means they can compact faster?
So like we create a actual spacing of them or
So yeah, so like if we just like compact them while jiggle them, so that's probably gonna help them to compact faster, right? To make them tighter faster, right?
mm.
Yeah.
Mm.
Okay. And so another method could probably be adding something else to the soil. Let's say some adding some extra chemical stuff to make the soil like more easily to be compact, right? That's probably another solution here.
Yeah.
So that gives us in total of like six crazy ideas. That's insane, guys. Well done. So that's the method one we've used for smart little people. I'll probably note this one down. So let me just grab a pen. So so what we have as Donnie's first idea. Sorry, Donnie, what's your first idea here?
First idea is intelligent compaction.
Intelligent compaction. And what's your second idea?
Moisture control.
Moisture control. Awesome. And Frank, what's your first idea?
I use the correct ruler
Use
for the different soil type. Yeah.
different kind of roller. And what's your second idea?
I reduce the thickness.
Reduce the soil
Soil.
layer thickness.
Yeah.
Thickness. Okay. So my idea was about the first one is the jiggling them, and the second one is adding some chemicals to change the parameters. Okay.
Okay.
So let's just keep those four six ideas in mind. Let's see how the different method, the treat method, are gonna give us the ideas. Okay. So I think you guys still remember how we're gonna do the treat method, right? Just to
Mm.
find the parameters for the contradiction first. So what we are thinking here, the contradiction matrix,
Mm.
the parameters we're gonna choose from.
Oh yeah, we definitely
Just
need
have a think.
street.
Have a 2 minute
Yeah.
think and just give me like numbers or it's
Oh,
fine.
okay.
Like
Mhm.
which two parameters are in contradiction. So, what two parameters are we looking at here?
The first one should be 9 or I think 25 also okay. But the best one is I think should be 9
Nine.
speed.
So, is
Mm.
that a improving parameter or worsening parameter?
First one.
Oh,
The
improving.
improving one, right?
Yeah.
Yep, that's cool. What's the worsening parameter here we're looking at?
I I chose 27 or 33.
27 reliability and 33 convenience of use.
Yeah.
That probably both work. So we will just try the
27.
speed to reliability first, and then we can
Mm,
see how speed and to convenience of use gave us, right?
yeah.
Okay, so this is the contradiction matrix. I will send this one in the chat. You guys can tell me what's the principal results coming from the matrix, okay? I will
Yep.
send this one in
Same
the
here.
chat. Let me send this one.
Do you need us to find off the word or just give you the number?
Number is fine.
Uh,
I'm just sharing
okay.
a link in chat. Yep. Okay. Cool.
11, 35, 27, 28.
Oh, 28. Yeah.
Yep.
So we're currently looking at that's
Speed and
nine the
uh,
speed to
yep.
27 the reliability. Okay,
Yep.
so what are the principles we're looking at?
Uh,
Sorry, what's the number again, Tony?
Uh, 11, 35, 27, 28.
That's awesome. That's awesome, right? Simple as that. It's the speed to reliability, and we just find the cell, the matrix cell that gives us the principles. Okay. And from there, we can see the improving parameter is 9 speed, worsening parameter 27 reliability, which gives us the four principles here. The 11 is the beforehand cushioning, and 28 mechanic substitution, 35 parameter change, 27 cheap short living objects.
mm,
Here are four ideas I think of based on the principle. The pre-wet soil before rolling begins, that's 211. Vibration drums jiggling, that's 228. And change layer thickness or rotor frequency, that's 235. And replace an expensive object with multiple inexpensive ones, that's 227. Is there any ideas you guys can think of about from those four principles?
mm.
So I think that's um for instance the 28 is very similar as what we said previously in the smart little people, right? The same idea happens here, the jiggling one. And the 35 change the layer thickness as the one Frank you mentioned
Mm.
about. And before hair cushioning, there's really a new one, and also the cheap short living objects. That's another new one. So we have sort of like developing two more new ideas from the trees method, the contradiction matrix method, along the smart little people. So let's have a look about Tony also mentioned about what's that one, Tony? You said it's the 33, right? Convenience of use,
Yeah, 33.
right?
Mm.
Yeah.
Convenience of use. Okay. So we go back to the contradiction matrix.
Uh,
That's gonna be 9 to 33. So what we are
thir-
looking at,
32,
32,
28,
28,
13, and 12.
32, 28,
13, 12.
13 and 12. Yeah.
30, and 12. That's awesome. Okay. Then we go back to the where's the
No, this one.
matrix table. It's gonna be this one.
Yeah.
So if we refer back to 32, that's gonna be color change. Does this apply to this content here? Color change?
Mm,
Material change.
Not really, right? The color
no,
change.
right.
So this is
Mm.
doesn't apply. It's okay. Sometimes the principle the matrix gave us, this doesn't really align with our actual problem. That's okay. So we just need to abandon this one. So then we check 28. Replacement of mechanical system. Probably that's your idea, don't you? The intelligent one, the
Yeah.
intelligent
Mm.
compactor, right?
Yeah.
That's probably another idea that's I resonate our smart little people idea. And 13, well, we're looking at the other way around. Anything we can think about that one?
Other way around.
The other
Mm,
way
yeah.
around. Yeah.
Use the concrete instead of the compaction.
Oh, interesting. That's brilliant. So we don't need no more need the soil to be compaction. So we just need
Yeah.
extra layers of the concrete, right?
Yeah. Just doing the concrete as a natural ground.
Interesting. Interesting. That's awesome. So this totally another new idea we've come up. So we now in total have nine different ideas. That's brilliant. And 12. So there's equipotential equipotentiality. So that's probably does that well apply? Maybe.
Mm. Wait, actually, not sure.
Uh,
Probably like different machines instead of like a roller compactor. It's like a
Oh, yeah.
yeah.
from
Oh,
the
you could
higher stuff and
potentially.
and compact down. It's the different type of machine we can use, right?
Yeah.
So it's similar as the one you mentioned about Frank. So like different type of roller, or we can just like
Mm.
explore that thing to like different type of machine we're gonna use. It's not only about different type of roller, right?
Yeah.
So like a nine and a half different ideas, right? Pretty good. Okay, that's awesome. So these are the six ideas I think of. So including the pre-white soil, the fabrication roller, the compaction layers, intelligent roller, and the swing soil, and replace with multiple cheap rollers. Probably with some ideas we've added on the well we have so the different machine, right? So I will just probably right here say 7. It's gonna be different machine. Oh, shit, it's hard to write.
Yeah. You can just read the DM. Yeah. We know what it is.
Okay, okay,
Yeah.
okay. So D
Yeah.
different machine DM. Okay.
Yeah. DM.
What we have for number 8, uh, the 8 different ideas. That's the what's the one we're looking at?
Or maybe it's the only thing I could replace the soil
Oh,
to
to
concrete.
concrete
Yeah.
replace.
like ground improvement.
Soil to concrete. Nice. And finally, number 9. What's number 9 here? So we've got the pre-wet soil, vibration roller, thinner compaction layers, intelligent roller resistance, some main soil stabilization replaced with multiple cheap rollers. What's the other one we're looking at?
Mm,
soil. Adding chemicals, right?
oh yeah.
Well, I mentioned so chemicals. Chemicals. Okay. So we have 9 different ideas here. And I will give you guys each 3 votes. You guys can choose like probably go voting, let's say voting number 1 twice. That's totally fine. So it's like a 2 plus 1, or you can go like 1 1 1 twice. Let's say 1 2 3. I will give them 1 each a vote. That's totally depends on you. So Frank, what you gonna vote? Use your 3 votes.
I'll give intelligent ruler 2 votes, cause cause this cause this idea will combine me and doing this idea.
Okay, so intelligent ruler, that's this one. That you're gonna give them 2 votes.
Yeah,
And
probably one for thinner compaction layers.
thinner compaction layers. Okay,
Yeah.
awesome. Tony, what you are thinking of?
So I just want to give the point to what I did before in my private project. So
Mm.
it's number one white
Pre-wet soil.
provide soil. Yeah, this one
Okay.
I used before, and this number three,
Number 3, thinner layer.
yeah, and number eight. So these
Number 8,
three,
replace soil to
yeah,
concrete. Okay. So we've got number 3 and number 4 for 2 votes. Probably those are the 2 ideas we can choose from, and from there we can then do a comparison. To do the comparison, we can introduce sort of like a scoring matrix to compare them in sort of like different situations regarding, or different factors regarding like cost or reliability or easy to use, and give them like a scoring factor and rank them to give us the best solution here. So that's pretty good. So that's awesome. And oops, sorry about that. And we will be going to the feedback section. So that's pretty much all for today.
Mm-hmm.
I will share this Google form in the chat. It's gonna be a short one. And please fill them out. And then once you guys fill them out, and just let me know, and we will just do another like short questions here regarding the feedbacks on the workshop. Okay, please use the link in the chat. I will send that one to you. Okay.
but do we need to do it right now
Yes,
or?
please. Yes, please. I'll give you guys 3 minutes.
Yep.
Yep, the link is in the chat. Can I guess access the form?
Yep.
Awesome. Okay, cool. I will I will share the screen of the Google form. So
So is that the last two Christian
Yep.
sim?
Last two question.
No, no, no. That's
Oh yes. Just
oh.
just just answer one, and for the another one just write an A. It's fine. I think I need to probably change that one.
Uh,
Yeah, duplicate it. Yeah,
yeah, I can complete it.
it's okay. Just fill either one of them is fine. Yeah. Another one just leave it blank or just write an A. It's okay.
Yeah, I turn it in.
Wait,
Okay, let me.
I need a little bit time.
Okay, I will just share that screen. Yep, I can see your response. So contradiction matrix. Okay, you're pretty confident on that one. Smart little people four. That's also good.
So it just one response.
Yeah, that's
Maybe
you.
I
Frank
need
is
to
filling it out. It's okay.
yeah.
It's okay. Yeah. Take a look on his one later on. So, what was the quickest, most useful moment for you into this workshop? Revise my original perspective. That's awesome. Thank you. What would you change about how this workshop was taught next time, face to face? Yeah, definitely. Yeah, I was trying to do this from face to face, but it's just like quite difficult to book a room in the unis with like a projectors. But yeah, definitely that's just really a good point to do. And I think for the duplicate question, I was meant to ask like, what's the like most difficult to understand part, or is there anything cause you confusion, or I can probably do it better next time? Is there any part you can think about?
I gotta submit.
Yep, cool. That's awesome. Okay, Frank, you've nailed it. That's awesome. Okay. I really like the analogy of the treating materials like smaller people. It makes the concept easier to understand upon different ways of thinking of me. Thank you. That's pretty good. It would probably be helpful to add a page number to each slide and print out the matrix for the in-person workshop. Yes, that's pretty much. So
Mm.
it's really hard to like share the stuff in a like online workshop. Even if I just like share my screen, it's quite like tiny to see. I need to like send them to you like directly, but that's not really easy to use. If you guys have like the matrix table printed in
Yeah.
front of you, that would be much easier.
Mm.
So as I said, for the duplicate question, another one I was meant to ask is like any like difficulties to understand or like confusion part you guys wanna like talk about, or some part like I could explain better.
Mm.
No, that's pretty good. I'm happy with that. Nothing. Okay, I will take it. Okay,
Yeah.
it's good. So you guys understand the concept well enough. I think it's really good.
Yeah, I think you provide a good provide some good example. So
Yep. Thank you. So we will jump to the final section about this workshop. Let me just share the slide again. So this one. So we need to think about how the teaching could be improved and rolled out more widely by applying the SMART plan, which means the specific, measurable, achievable, realistic, and time-bound. So probably we three can discuss all together, thinking about any like particular solutions we can think about just to make it this teaching improve or like can roll out more widely.
Yep.
Uh, any ideas, guys?
Uh,
Probably I will just like give you guys 5 minutes to think about this one first, or and we can just have a chat together. I will probably think about this one myself as well. And we can have a chat in 5 minutes. Okay?
Okay.
Yep. Sounds good. Okay, so do we have any ideas?
Maybe you can make a short video and send to social media like YouTube and TikTok.
So you're thinking about
Mm.
like how to roll out more widely, right?
Yeah.
Yeah, I'm also thinking about that one for like short video. So probably I can. So for this workshop, we probably gonna we take around like 70 to 80 minutes. So that's really a long time for a workshop. So let's say if I can record this workshop or like the ideas about the smart little people and the matrix idea by myself, that will probably take me around like 20 to 30 minutes, maybe 20 minutes. And then just to make that as a short clip, we can share that to as many people as we want. And then we can do a regularly um, QA session about the ideas, like all any questions the audience have after watching the video. Probably we can run that one, let's say every Sunday for an hour. So that's probably gonna help us to roll out this one more widely. So not everyone have questions for like every different slides. If I let's say to do workshops for 10 people, so they all might gonna take me like I don't know, like 1 hour each, maybe. That's gonna be time hours. So if I share the short clips to them, that's gonna only take them like half an hour to watch and probably another 15 minutes to think about and ask me questions. Or we can sort of create a discussion board so they can just like post questions there and I can answer their questions. So let's say like Frank, you got a question regarding something, and probably has the same question about that one. So if you share that question, post that one on the discussion board, I can answer a question. Also, Tony can see that question, so he doesn't need to like ask me again, right?
Oh,
That's probably
okay.
a good way to go. So yeah, so probably I probably can like let's say create the short clip by the end of this week, and then we can share the video and run a QA session every Sunday afternoon for an hour. Also create a discussion board like by the end of this week. So that's probably a good plan. Yeah, that's option A. Is there any other options we can think about?
Uh, I I think maybe Donnie and I can set up how to say that, an internal workshop in our company, right? And
Yeah, that's
share,
also like roll
yeah,
out more
share this
widely.
idea,
Yeah. So
yeah, to
you
our
guys
colleagues.
understand your colleagues, you know each other, and you've come from the same background. That's probably a really good idea, and that can also apply the method we just talked about, like just like short clip and another like QA session you guys can run internally. That's probably another additional one. Yeah, that's pretty good.
Mm,
And another method I'm thinking about probably just do a single tool session instead of like two principles we've talked today. So just like half the times
mm,
we need for the workshop, right? So we today we've come we did like two different principles, two different tools for creative thinking. But if let's say we just do smart little people for today, that's probably gonna
mm,
take us like 40 minutes, 30 minutes. So that's probably gonna be easier to have you guys all keep your attention in and just don't get lost, don't get bored, and that can probably also help the session to roll out more widely, maybe. So more people can easily take like half an hour, but like ask them to spend another like 1 hour and a half, that would be insane, probably. That's gonna be crucial. Yeah, that's another method. So um yeah, so to think about like smart ways. So specific, we've talked about that. Well, it's just like keep it 30 minutes for each session, do a single tool, and measurable is just like having them record it. Achievable, yes, realistic, yes, time bound, probably like once a week for this, or like twice a week for this single tool session. So let's say Saturday we're doing like small little people, and Sunday doing the trees, the matrix one, the contradiction matrix. Yeah, that's pretty good. I think we've got like 2 small plans. Awesome. Is there any question to ask, guys?
No question.
I think all good.
Awesome,
All good.
awesome. So thank you guys so much for joining me today for this workshop. It's great to have you guys. Thanks so much.
Okay, thanks
Thank
to
you.
share
Cheers.
the
Thank you.
it's
Cheers.
Yep.
Bye bye.
Cheers. Bye.